Hey there, we are the Study Buddies. In today's mathematics addition video, we'll be looking at discriminant of roots. So let's begin. So just to inform, discriminant of roots is actually just the continuation of the previous video I made, which was quadratic equations. Okay, so let's begin. So if you look at this formula, I think you by now would have been familiar with this formula. Yes, this is the quadratic formula which we use to find out the value of x whenever given a quadratic equation of ax squared plus bx plus c. So how do we find out? We take the values of a, b and c and we substitute inside this equation. So what is discriminant and roots? So discriminant and roots start off from this part, which is the b square minus 4ac part, which is called as discriminant. So why is it called a discriminant? Discriminant is a one which determines the properties of roots. So now we'll be looking at a few properties of roots. So the first property would be b square minus 4ac greater than 0. So let's say when you substitute the values of a, b and c into the calculation b square minus 4ac and you get a value greater than 0, this means that you are going to get an answer of two distinct roots. So what does this mean by distinct? Distinct means different. So what the answer is, what this actually says is that if when you do b square minus 4ac you get an answer greater than 0, this means x will be two answers. So which means like x can be 1 or -1, something like that. Okay, so in this case the graph would be drawn in this format: a curve which touches at 2 points on the x-axis. So that's why we say two distinct roots. So let's say if it's a b square minus 4ac greater than 0, the graph would touch 2 points on the x, thus producing two values of x, which means two distinct or two different roots. So this is the first property of root. So now we are going to look at our second property of roots, which is b square minus 4ac equals to 0, which means that whenever you substitute the values of a, b and c into the equation, you're going to get an answer of 0. So whenever you get an answer of 0 after substituting inside, it means that you're going to get two equal roots. So what does two equal roots means is that you're going to get only one value of x. So that's why when you look at this graph, which is actually y and x, you notice that it only touches 1 point on the x, indicating that only one value is produced when you get equal to 0. So don't worry, later I'll be showing some examples for each of these properties, and at that part we can grasp clearly what I'm trying to explain. So the third property of discriminant of roots is that b square minus 4ac is lesser than 0. So when you substitute a, b and c individually inside this equation, whenever you get a value of lesser than 0, which means you're going to get two complex roots. So what is complex roots? So complex roots, which means you're going to get some kind of complex numbers. So if you want to know more about complex numbers, so please watch my previous video on complex numbers. So complex numbers are numbers which have an I or a set of -1. So whenever you get a lesser than 0 value, it is confirmed that x is going to be equal to something which has an I together with it. So these are the three properties of discriminants and roots, of roots. So now let's look at a few examples. So let's take a look at this example: x squared minus 2x minus 3 equal to 0. So first step, whenever you look at this question, find out the values of a, b and c respectively. So once you find out the values of a, b and c respectively, substitute inside this equation, which is b squared minus 4ac, the equation we saw just now, and find out its properties, whether it's lesser than 0, greater than 0 or equal to 0. So let's begin. So b is -2 square minus 4 times 1 times -3. So -2 square, you're going to get 4. -4 times -3, you're going to get +12, which brings an answer of 16. So 16 is greater than 0, thus b square minus 4ac is going to be greater than 0. So in this case, this means that this is going to give two distinct roots. So let me prove this to you by doing the factorization of x square minus 2x minus 3. So x square minus 2x minus 3, after I do this method, which is the complete factorization method, I get an answer of 3, negative 1, so negative 3, 1. So I'll be getting negative 3x and x, which will give us negative 2x. So after I factorize, I'm going to get x minus 3, x plus 1 equals to 0, and therefore the answer is going to be x equals to 3 or x equals to negative 1. So if you realize now, actually there are two answers, which means in the graph is going to touch at points negative 1 and 3. So therefore, this has actually proved that there are going to be two different roots for this question. So this is why we say that this equation can determine the properties of roots. So now let's take a look at our second example, x squared plus 2x plus 1. So I took the values of a, b and c already. So let's begin. B squared minus 4ac is equal to 2 square minus 4 times 1 times 1. So 2 square, you're going to get 4 minus 4, which equals to 0. So as I mentioned just now, if it is an equal to 0, therefore b square minus 4ac equals to 0. This means that you're going to get two equal roots. So let me prove this to you. So let's say I rewrite x squared plus 2x plus 1 equals to 0 again, and I'm going to do the complete factorization method. So 1 times 1 is just 1 and 1, therefore we are going to get x, which is going to bring us to a 2x. So therefore it's going to be x plus 1 times with x plus 1 equal to 0. So x plus 1, you can just simplify it into x plus 1 square equal to 0. And therefore the answer is where x equal to negative 1. So if you notice properly, now there's only one x, which means two equal roots. So both roots, which is if I do this individually and if I do this individually, I'm still going to get negative 1. So in the graph, it's going to be something like this, where it just touches, it's going to just touch negative 1 only on the x-axis. So let's take a look at this third example, x squared minus 2x plus 5 equal to 0. So I have took out the values of a, 1, b negative 2 and c positive 5 respectively, and I'm going to replace it, and I'm going to substitute it inside this equation, b squared minus 4ac. So negative 2 square minus 4 times 1 times 5. So we are going to get a 4 here minus 20, which is going to bring to an answer of negative 16. So negative 16 is lesser than 0, and thus b squared minus 4ac for this case is lesser than 0, which is therefore going to bring two complex roots. So what does two complex roots mean? As I've said just now, we're going to get a value of I or something like that. So let me prove this to you. So to prove this to you, I'll be using the quadratic formula because I know that the answer is going to be a complex number. It would not be able to use complete factorization method. So let's begin. So negative 2 plus minus square root negative 2 square minus 4 times 1 times 5 over 2 times 1. So we are going to get 2 plus minus 2 to 4 minus 20 over 2. So 4 minus 20, we are going to get negative 16. So can we simplify negative 16? Of course we can. We are just going to make it square root 16 times square root negative 1 over 2, where this square root negative 1 is now a complex number, and we are going to change it to I. So square root 16 is actually 4i. So now as you've seen, you would have noticed by now that there is a complex number, and that's why I was telling that this is a complex root. And how do we get two complex root now? Since there's a plus and minus here, we can split them into 2, where we're going to get x equals to 2 plus 4i over 2, and or x equals to 2 minus 4i over 2. So we can simplify this by removing the 2. So 1 minus 2i over 2. So cut off the 2, and we're going to get 1 plus 2i and 1 minus 2i. So therefore this would be the answer for this question. So that was why when we did b square minus 4ac just now, we got a lesser than 0, and I told 2 complex roots. And as a proof, here you go, 2 complex roots. So why? Again, just a recap, b square minus 4ac is actually a determinant of the properties of roots. So the three properties are 2 distinct roots, 2 equal roots, and 2 complex roots. So if it's 2 distinct roots, it is greater than 0, 2 equal roots equal to 0, and 2 complex roots lesser than 0. And so that's all for this video, guys. If you like this video, do like this video, comment if you have any doubts, share this video to your friends, and don't forget to subscribe and click the bell icon. That's all for today. Thank you, take care, goodbye.